What is carbon monoxide? Carbon monoxide is a poisonous, colorless, odorless, and tasteless gas. It is produced when fuels such as gas, oil, charcoal, and kerosene are combusted. However, it is the product of all incomplete combustion reactions. Common sources of carbon monoxide include cars, fireplaces, and gas appliances such as water heaters and ovens. Carbon monoxide is sometimes referred to as a silent killer because of its incognito properties like its odor and color. It can be very hard to detect and becomes a danger when inhaled at excessive levels. So, what makes carbon monoxide dangerous? When inhaled, carbon monoxide replaces the oxygen in your blood. Without oxygen in the blood, vital organs such as the heart and brain become deprived of oxygen and stop working. Large amounts of carbon monoxide can overcome you in minutes without warning, causing you to lose consciousness and suffocate. This is known as carbon monoxide poisoning. According to an article written by CBC, 380 Canadians died from carbon monoxide poisoning between 2000 and 2009. Many die and others can be permanently disabled. You cannot smell or see it, and it kills. According to the Ontario Association of Fire Chiefs, 88% of all homes contain a carbon monoxide threat. Nearly everyone is at risk. According to John P. Cunha, common symptoms of carbon monoxide exposure include fatigue, shortness of breath, dizziness, seizure, vomiting, and headache. If these symptoms are experienced by more than one person in your household, there's a better likelihood of there being a leak in your home. If you have symptoms that may be linked to carbon monoxide poisoning, call 911 and seek fresh air immediately. Now that you know that carbon monoxide is a threat to many important components of the human body and are aware of the symptoms to watch out for, it is time to talk about how carbon monoxide affects our body on the cellular and molecular level. Oxygen is necessary for all humans to survive. It is a vital part of cellular respiration and is a necessary part of all our cells' survival. However, we need a way to get to the oxygen to all of our cells. This is done by the blood, which also delivers the other essential nutrients which our cells need transported to them to survive. We obtain oxygen by breathing in air, which contains a minimal percentage of oxygen. The oxygen diffuses through the capillaries in our lungs and enters the bloodstream, traveling throughout our body. Within every drop of blood, there are millions of red blood cells. The red blood cells gain their red color due to an important compound which comprises them, known as hemoglobin. This protein, hemoglobin, is the key to oxygen transport. A hemoglobin molecule contains four heme groups, each surrounded by a polypeptide chain. Each heme group contains an iron molecule at its center, which is necessary for the molecule to be able to transport oxygen. Every heme group can attach up to four oxygen molecules if the molecule is fully saturated with oxygen, making it an efficient way to carry oxygen around the body. The reaction which takes place looks like this. The decomposition of the oxyhemoglobin occurs at the same rate as a synthesis reaction with the reactants hemoglobin and oxygen. Therefore, this reaction is at equilibrium. The bond between oxygen and hemoglobin, more specifically the heme groups, is not very strong, which allows the oxyhemoglobin to lose the oxygen molecules to transfer to the cells in the body which need them at that time, therefore allowing the reaction to stay at equilibrium. As discussed before, carbon monoxide poisoning is very dangerous. I'll explain why. According to Yvonne Blumenthal, carbon monoxide is 200 to 300 times more attracted to hemoglobin, and oxygen is already fairly scarce, making up only about 20% of air. When carbon monoxide is released from incomplete combustion from, say, an engine of a boat or a car, these levels can build up, especially in tight spaces. Due to the increased attraction of carbon monoxide to hemoglobin, it doesn't take much for the carbon monoxide levels to become dangerous. The carbon monoxide is taken in the exact same way oxygen is taken in, through the lungs, diffusing through the capillaries and bonding to the exact same spot of the hemoglobin that oxygen would. Therefore, the reaction ends up looking fairly similar. Hemoglobin and carbon monoxide create a compound called carboxyhemoglobin. Due to the strong attraction the carboxyhemoglobin has within this compound, the equilibrium constant K is much larger for this equilibrium reaction compared to the hemoglobin oxygen reaction. The production of carboxyhemoglobin is favored, therefore leaving much less of an amount of hemoglobin to bond to oxygen, which limits oxygen transportation. The loss of the ability to transport oxygen throughout the body is devastating and can be fatal. Carbon monoxide poisoning can cause death within minutes because the loss of oxygen leads to the death of cells and damage to major organs. The effects can also be long term, with approximately 40% of surviving victims having long term problems such as amnesia, loss of muscle and bladder control, vision impairment, and constant headaches. Doctors use the laws of equilibrium and Le Chatelier's principle to their advantage to create a treatment for victims of carbon monoxide poisoning. According to Chemistry LibreText, Le Chatelier's principle states that if a dynamic equilibrium is disturbed by changing the conditions, the position of the equilibrium shifts to counteract the change to reestablish equilibrium. which is similar to a balanced seesaw. Since the oxygen and carbon monoxide are competing with each other for the hemoglobin, the equilibrium reaction which occurs with carbon monoxide poisoning looks like this. The treatment used is simply giving the patient pure oxygen. Giving pure oxygen increases the amount of oxygen in the reaction vessel, and applying Le Chatelier's principle would cause the reaction to shift left, increasing the amount of oxyhemoglobin and carbon monoxide. Increasing the amount of oxyhemoglobin produced is necessary because during carbon monoxide poisoning, there's too much carboxyhemoglobin and no oxygen can be transported to our cells. The extra amount of carbon monoxide produced from the reaction shifting left is not bonded with hemoglobin, therefore exits through our breath. According to CDC, some tips to prevent carbon monoxide poisoning are setting up carbon monoxide detectors and changing the batteries every 6 months, never leaving the motor of your vehicle running if your vehicle is in an enclosed or partially enclosed space, such as a garage, never using a charcoal grill, lantern, or portable camping stove inside a home tent or camper, testing gas appliances for leaks and or damage, and never running a motor vehicle, generator, pressure washer, or any gasoline-powered engine less than 20 feet from an open window, door, or vent where exhaust can vent into an enclosed area.